All right, so I'm going to give people a few seconds to roll in. All right, so normally around this time I stream The Office. So I've been doing this data viz project about The Office, but today, in honor of our studio conference, our studio global, whatever they're calling it, I thought that I would stream some coding with R. So what I've been working on lately is a new generative art system, and I'm just going to keep going on it. I'm still at the early stages of this system, so it's still got a lot of work to go. Things are not pretty, the code is still terrible, it's all fluctuating, things are not even in variables, things are not functions, so this is very early days. And I'm going to maybe experiment with a couple of features, maybe turn some stuff into functions. We will see. So this is mostly based around Bezier curves, and I've been trying a bunch of different ways basically to generate the control points for the Bezier curves. Let me get a couple of my functions loaded here. Okay. Get rid of that. Okay, so you can see after all this junk up here, I finally get down to the good stuff. This is what I've been working on recently. And let me just run this and make sure it works. A lot of times it doesn't because I've changed something, forgetting to rename a variable or something, but forgot to, actually update it. Okay. This still works. Nice. So this is what we're making. And this is like the debugging view. So right now I have what this system is doing, or at least this code that I just ran is doing, is it sets a start point and an end point. So the one with the circle, this is a start point. And then it generates a set of control points that are nearer the start point. That's these ones, and then it generates another set of control points, and then using the start and the control and the end, it draws a series of lines between those that are Bezier curves. So it draws a series of Bezier curves between the start and the end based on these control points that I've generated. And yeah, this is all parameterized, so there's many different ways. What I've been experimenting lately with is different ways to generate the control points. So to start with, I generated them in arcs, then I generated them in straight lines, and this most recent iteration generates the control points along a Bezier curve. So this is not code that I ever actually intended to show to anybody, but it's what I'm working on, so I decided why not stream it. You guys can see my terrible, awful code. But basically what I'm going to do today is try to add a couple of features to this, and possibly like actually start parameterizing things so it's easier to work on. You can see that I already sort of started parameterizing things a little bit. Up here, this is some of the parameters, like this is the number of lines that we generate, so I could generate 50 lines instead. And twist means whether or not there is a twist between the start and the end point, so you can see what that means if I set this to false. I'm crossing my fingers that this works, because again, this code is very brittle and not tested. This is very like one-off. This is sort of how I develop generative systems, starting very unprincipled and then going more from there. Okay, so this worked. So this added 50 lines, and now you can see there's no twist in the middle of these between the start and the end point. And if we rerun this, there's a lot of randomization in here. And most of that is not yet parameterized. It's just like hard-coded values that I set like sample between this and that. But if I keep running this, it'll keep generating new versions of this Bezier plot thing. That one looks kind of nice. I like that one. So anyways, let's begin. I think what I'm going to start doing, and if you have any questions, go ahead, throw them in the chat, say hi, tell me what you liked about RStudioConf. Yeah. So what I'm going to start with is right now I am generating these control points along a Bezier curve. I'm going to continue to do that, but I want to add a little bit of jitter to the points. So right now they are evenly spaced along that curve, and there's no like variation. So what I want to do is add a little bit of jitter, or perhaps a lot of jitter, depending, and just see what happens. So that we start with these curves perfectly on this line, or these points perfectly on this curve, and then we, start moving them a little bit randomly. So let me figure out how to do that. And you can see there's a lot of stuff going on here. Basically all of this is just to, and this too as well, is just to make sure that these points get drawn in a sort of principled way. So it's to make sure that they get drawn, not too far away from each other, not too far towards the center, not too far towards the origin, stuff like that. So where do I want to add the jitter is the question. Probably after they've been actually generated. So this code down here is what actually generates the control points. This is using a package called Bezier, and the real key part here is this function. So you say points on Bezier, and then you give it a set of, with a Bezier curve, you need a start point, an end point, and some control points. So that's what you do. And then it generates, end points along that Bezier curve that you defined. So then once I have those points, like we can inspect this variable here, CP start. So this is the control points that correspond to the red here. And CP end is the control points that correspond to the blue here. So this is just a very simple set of XY coordinates, and this is probably the best place to start adding that jitter to that I mentioned. The big question is going to be how much to add. So let's just start adding some random amounts. Why not? Oh, my camera is over the plot. Thank you. That is a good point. I did not think about that. Let's move this over here a little bit. Let's see. That's slightly better. Yeah. I don't need this code to be that wide anyways. That's probably better. Yeah. Thank you, Johannes, for pointing out that my camera was covering up the plot. All right, so yeah, I'm just gonna add some jitter to here. This is gonna be like really basic. There's a lot of like fancy ways that you could do this, but I'm just gonna start out simple. My goal is usually start out very simple and then sort of build from there. So I'm just gonna go for it. So if we take CP start, I'm gonna assign this to a new variable for now. Oh, hey, Robert is here. Yeah, this is not office related. Yeah, I thought I'm doing a sort of special generative art stream, just because I felt like it, and B, because today was the first day of our StudioCon Global, so they had a whole like remote conference. So I thought I would do something in R, but I didn't really have anything to do except this generative art thing I've been working on. So yeah, I decided to do that. But in case you are curious, Robert, I will give you a sneak peek of what I've been working on with the office. So this is our office project. So I've been struggling a lot with like figuring out how to lay things out. And then I sort of realized, also after talking to my friend Gabby, I realized that this doesn't have to be like perfectly gridded. It could be very sort of loose if it was structured like a computer screen. So I'm working on this sort of Windows 95 aesthetic for the office project. So this is a very rough work in progress, but I'll probably return to this next week. You'll see more of this next week, but we have some little post-its, we have some windows, we have some classic clouds background from Windows 95 for anyone that has that nostalgia factor. So yeah, that's where I'm headed with that. But today we're gonna make some art. Yeah. All right, so I have this, Robert, by the way, I have this, the system I'm working on is all Bezier curves, and what I'm gonna do now is I'm gonna add some jitter to the control points. So I've been generating these control points, but they're like very straight and like perfect, so I'm gonna add a little bit of jitter to them. And I'm probably gonna fail at this because I've been not coding in R recently. Okay, so how do I want to do this? I want to just add like, I think I'm just gonna start out by like sampling a random amount between some small values and just adding it to the X and adding it to the Y. It's a very naive way to do this, but you know, it should work. The trick will be tuning how much you want to add to each point. And probably, like possibly also tuning the distribution. So initially I'm just gonna use a uniform distribution, just like sample randomly. So let's say like X jitter equals, also I don't know if this is gonna work because I kind of forget how dplyr works, so I'm gonna try a couple of things and this might not work. So I'm gonna do like sample from like, let's say negative 0.5 to 0.5 by that. And we will sample one of those. So this is gonna equal X plus this. My question is, I think this is gonna generate one value and then add it to the entire column. And that's not what I want. So let's see what that does. Who knows how anything works without Stack Overflow? Yeah, that's a good point. That's a very good point. Okay, and to do this, I'm just gonna start visualizing this by just saying like ggplot. This is how I'm going to debug this, is ggplot, and this is like super simple. I would have just done this in like 10 seconds if this were a year ago, but I kind of forgot how to code with R, so. Geom point data equals cp start. And then color equals red. So I'm going to plot the original data. Next to the jitter data, and see what happens. Yeah, I think that just shifted the entire thing over. So I think what this did was just picked one sample and then shifted it over. What if I do this? Is this gonna work? Okay, that is what we need to do. So we need to sample the same number of rows that we have, and then that does vector addition. Now I can already see that this is probably way too much jitter. So I'm just going to turn this down to 0.2 instead of 0.5. And then I'm going to copy and paste this down here, and we'll say y jitter is y plus the same thing. Oh. What did I do wrong? Oh. Wait, cannot take... It worked before. Why did it just stop working? Cannot take a sample larger than the population when replace equals false. Input x jitter is x plus... It shouldn't be larger than the population though. Okay, let me just back up and see. Somehow it really didn't like the fact that I did that, or maybe this just randomly, okay. For some reason this just randomly worked the first time, and it's unclear why this worked. So this, we should be taking this many samples. Okay, maybe there was just something about that that it didn't like. So then I'm gonna do this, same thing with y. Nice, that seems to work. Ah, cool, Matthias is here. Nice to see you coding in R. Yeah, I thought I would do some generative art in R. I thought I would do something in R. I figured I would just mix it up a little bit, do something a little chill. Because today was R Studio conference, so I figured in honor of R Studio conference I would do something in R. And what I've been working on recently, the only R project I've been working on is this generative art system based on Bezier curves. So that's what I decided to work on. Also, Matthias, by the way, I watched your Svelte Society talk on the balloon project thing again, and I've been I have someone who I mentor I'm working on a project with them, and we're working in Svelte. And we are planning to make a very, very similar plot where it's some chart up top with stuff, but little dots that's connected to a map with Bezier curves. And we're doing it all in Svelte. And so I was like, okay, basically to learn how to make this, just go look at this repo that Matthias has and then copy what he did. Because I was like, whatever he did is probably better than what I would have come up with. So just go copy that. Yeah, your code is really good though. Okay. So okay, so I think the way I should do this is that now what I will do is I will shift this code up here. Oops. And I will just say x equals and y equals. And then what I'm going to do here also is I'm going to actually start using parameters instead of just hard coding everything. So I'm going to say jitter min is like 0.1. Let's just make it really small. And oh wait, we want this to be negative. Or no, it doesn't matter because, yeah, I'll show you what I'm doing. Does this even need this? If I'm always going to make it symmetrical possibility, I guess I don't really need. I could just have like, I could just have one that just says jitter. No, I do want a min and a max eventually. For now, I'm just going to do one. Because I know that I'm going to make some jitter in here. Okay, so I'm going to do that. And then, God, there's so much crap code here. Okay. So we're going to say negative jitter to jitter. Same thing up here. Okay, nice. And then I'm going to do the same thing with the endpoints. So, or the end, it's not really the endpoints, this is actually the end control points. Okay. Oops. You can see I've even forgotten the I've even forgotten the all the key bindings in RStudio. Okay, let's run this control point code again. Now that we've added jitter. Do I have this code on GitHub? Ooh, no, definitely not. This code is not on GitHub yet. It should be on GitHub in a private repo, because I should be backing it up, but I've just been working on this for like this week, so I haven't put it on GitHub yet, which is terrible of me. But yeah, this is just for me. I don't think this one is going to end up on GitHub, because this is like, you know, this is like one of those things where I just don't want people to look at the code. I'm just gonna like, I'm writing it for me and for me only. And I don't want anyone else to look at my terrible code on this one. So, but always happy to answer questions about how I did anything if people have questions. So I'm taking the Thomas Lynn Peterson approach with this one, where I'm going to be very mysterious about how the code is done. Except I realize now that I'm not doing that at all, because I'm live streaming this and it'll be on YouTube for eternity. So, or until the heat death of the universe or whatever causes YouTube to go down. So, but yeah, I'm not going to publish this one or write it up as a blog post or anything. Okay, so what went wrong? I did something wrong. Invalid argument to unary operator. I don't know what that means. Does it not like that I said negative jitter? What if I just say negative 0.1? Did I actually forget to define jitter? That's also a very, very good possibility that I actually forgot to define it. Indeed, I forgot to define jitter. Okay. I wrote the code and then I didn't run it. Classic. Okay, now this should run, right? There's no way it fails a second time. No, it still hates me. Okay. I had this problem before. So I should be sampling the same amount of points that are in this. Oh. Maybe I'm not, though. Maybe I am not doing that at all. Okay, so let's try something new. Instead, let's say this. Maybe just like for some reason it doesn't like that I'm trying to do that all in one line. No, it still hates me. Cannot take a sample larger than the population. Does it have to do with this? Oh. It's because I was so tiny in the amount of... Really? There's only 30? Yeah, I guess that's true, actually. Okay, so we're gonna do this so that we can... Okay, first we're gonna back up, because I actually was fine to begin with. The reason this wasn't working is actually because the sequence I was generating was less than 50 or less than 30 things. So, okay. I could also just do length.out equals like 200. Like we're never gonna want to draw more than 200 lines, right? That's... Yeah. In fact, if I'm really doing this the right way, I should just say like lines times 2. That's probably a better way to do it. And that will ensure that we never, ever, ever have too few samples. And I'm also gonna... I just realized that I actually do want to replace... yeah. I do want a sample with replacement in this case, because why not? I don't really care if it uses the same jitter twice, so... Okay. Last time. It's gonna work. It's gonna work. Hey, it worked. Okay. So now what we have done is generated, we have a start point and an end point. So to build a Bezier curve, if you don't know, you need a start point, you need an end point, and then you need some number of points in between, usually 2. I always forget if 2 is cubic or quadratic. I think it's cubic, I guess, so, or quadratic. I don't know. Anyways, I have start point, end point, and 2 control points. And so the start point and end point are the same for all these lines because they always end up at the same point. But the control points are generated along a Bezier curve. And so now we've added jitter to them. So this is our this is our control points that are going to be for our lines. Then what we have to do is to generate the actual final Bezier curves that I'm drawing. This is very confusing to explain because I'm like just saying Bezier curve over and over again. But to generate the final Bezier curve that I'm drawing, I'm using this Geom Bezier, which takes a very specific data structure. And so this code here just takes that start point and end point in those data frames of control points and turns them into the appropriate data structure for Geom Bezier. Aha! It worked. Interesting. That was very interesting looking. So like, Zoom in actually. So you can see that we can definitely see the impact of jittering. That was like, it had more impact than I thought it would, in fact. Yeah, that's kind of cool. I think even with like, I could even put less. Like I have the jitter maximum amount at 0.1. I honestly think it could even be less than that. I think it could be like, so I also want to make sure, first of all, this should be the case unless I'm just really dumb, but if I set this to 0, there should be no jitter whatsoever, and it should just plot like it did before I added the jitter. So I want to test that to make sure that is true. Indeed. Okay. So this is what it looks like just generating these points evenly spaced with no jitter to them at all. And then what if I make it like 0.05? I'm also going to add a twist and see what happens. See what it looks like. And make sure it works with the twisted one. There's no reason it shouldn't. It'll work, but just to see what it looks like. I don't like that one. Let's make a new one. Yeah, cool. It's kind of interesting. I feel like it ends up having a lot of these little doublets, which I guess is expected. I wonder if it would be different if I made it not symmetrical, the sampling. So like, what happens if I increase? Yes, that's an excellent question. That's always the next question. Matthias is thinking like a true generative artist. So some of the coolest things in generative art, like when you add something like jitter like this, and then you're like, oh, okay, it looks cool with a little teeny tiny bit, because like that's what you were thinking in your head. But then you're like, what happens if we make it like 15? And sometimes it's really cool. And then you try like 10,000, and it's usually insane, and it doesn't work, but sometimes it does. I feel like this is just random, right? This is just total randomness. There's no order at all. I don't think this is even like, yeah, that's funny. But I think, and then you can dial it in, right? So you do 15 and you're like, okay, it's kind of random. But what if it's like 1? Maybe that's, maybe that's like the sweet spot where it's like really funky, but not, it still has some order to it. Yeah, that's kind of cool, right? I like that one. Let's make like 40 lines. Why not? Yeah, cool. I like it. I think it's cool. This is a place where it would be fun to have like sliders to play around with all these parameters. I think like I've done that before in R, where I made a package for generative art for making these glyphs, and it was kind of it wasn't a similar algorithm in any way in terms of like what it produced or like how it worked, but it was similar in that it was also like basically just a crap ton of lines of like trigonometry with a ton of different like samples and randomness. And so, there were like 30 parameters to adjust or something. And so I made a Shiny app to adjust all of them. Yeah, so that's what Matthias was like thinking ahead. So yeah, I made a Shiny app to do all of them. But I'm probably not going to do that in this case, because honestly, like I did it because it was like an art project, and that was part of my like 12 months of art thing. And so part of the reason I was doing it was to teach other people. And I realized at some point that like no one will be able to use this code except for me unless I make an app out of it. But I found it kind of annoying to develop the Shiny app. Part of that is that I'm not very good at Shiny, so I had to like troubleshoot a lot of very weird Shiny specific problems. But like to me, it's not worth it to invest, the like, I don't know, several hours it would take me to turn this into a Shiny app, because I can just adjust the parameters in the code. I would like something. I know like in JavaScript, for example, the reason I'm thinking of this is because in JavaScript, I think in like processing, I think it's processing, or like P5, where it's like really, really easy to make sliders. Like you can just like up here where I'm defining all the parameters, I could just be like slider, twist, and like, or like slider, lines, and it would just like do it and it would pop up on the screen. But you know, obviously R is not like web native, so to do that wouldn't make sense. But I wish I had that functionality. That's one of my weird art specific. Matthias could offer a Svelte component. Can you make Svelte work with R? Is it possible to do that? I don't know if I've ever seen. I know they made React work with R, and I think maybe they made Vue as well. Like I assume you could, because it just compiles to vanilla JavaScript, right? And you can do stuff like interfacing with R and JavaScript, but I don't know if I've ever seen anyone do it with Svelte. Yeah, D3 also works in R. Yeah, like you can export stuff with like HTML widgets and all that stuff. So I know like you can do that, and I think there's like some package in R, like V8, which I think is just a generic like JavaScript engine. So you can definitely do that stuff. Ooh, Johannes linked something. Maybe this is like a risky click. You're not supposed to click on stuff from chat, I've learned. But I trust everyone in this chat. I'm pretty sure I know all of you, so you're not going to send me some virus through a link or something. Create a slider control. Manipulate interactive plots for RStudio. Well, that sounds like what I want. Oops. I'm not supposed to send links in chat. No, you can send links for sure. Please continue to send me links. I trust all of you, but like, okay, so this doesn't matter for me because I have like 4 viewers right now, and so like no one's gonna send me like a virus. But I know that, for example, you know, in streams where people have like, you know, like 5,000 viewers or something, they're obviously gonna get trolls that link, like they're gonna send you a link in chat like, hey, open this cool thing, and it's like porn or a virus or something. And then, you know, the streamer will open it and be like, okay, so it's like risky click if someone sends you a random link and you're like, should I click on this? Should I not click on this? But I trust you, Johannes, so. Interesting. I might try this out at some point. I don't know if this works. Does this work with ggplot? Or like, does this work with like custom, this works with like with plot, like the generic R plot function. It doesn't seem like this works with like random code. Like I couldn't put like slider here, like slider or something. You'll try it. Okay, cool, you try it. Let me know. You can report back. Yeah, I got some other stuff to do, I think. We got some stuff to do. So, I did jitter. Another thing I was gonna do, maybe next on the list, what we'll do next is I mentioned that right now these lines all have the same start and end point. I wanted to let those start and end points vary. So I figured instead of having them all be the same, so I like this, but I also want to be able to try what it looks like when each line has a different start and end point. So to try that, I have to find, where am I? Okay. This is going to be kind of tricky because, well, okay, so the issue I'm thinking of now is like I could easily just use the same method I use to generate control points to generate the start and end points. The issue is that a lot of my code for generating these control points stems from having a single start and end point. So it stems from like knowing that this is the start and this is the end. Now, I think I can deal with that basically by just continuing to have this exist. And so like continuing to have like this, and then this would be like the midpoint. And so from here, we'd like fan things out. Yeah, I like that idea. I'm gonna try it. Yeah. So right now I've actually put the start and the end up here in the parameters, but I'm gonna move it down here since I am going to change that. So I think I'm gonna basically keep this the same. And like eventually I'll rename all these variables to like start, midpoint, x or whatever, but I'm just gonna leave them the same for now. And then, okay, I'm also gonna do something. This is what I've been doing, and it's why I have so much random code up here, and it's not like a good way to do this, but I'm going to copy this into a new R script so that I don't destroy my previous code in case I want to use or change something with that. Okay. So now let's say like generate start and end points along a circle. There's various ways we could generate the start and end points. I'm going to start with a circle because it's easy. So we have the midpoint for that circle, and now we need to say start R. So this is going to be the radius of the circle for where the start points are going to go. We're going to do my classic. I should really write a function to do this because I write this code non-stop basically. Seek from like I don't know 0.1 to like 3, and we'll change, like these will be parameters eventually, but as I'm developing I do this a lot where I just kind of you know, write crappy code basically. So that's the R, and then we need to know the start. We need to know what the angles between we're going to generate. So I'm not just going to generate a circle of points. I'm going to generate like, you know, an arc. So I need to have like a start angle and an end angle to know like where I'm going to generate those. Now, something important would be which direction that... I guess it doesn't really matter, actually. There's a way in which I make it... So what I'm thinking of is, do I care if, like, this is the start point and this is the end point? So do I care if it generates an arc, like, over here? Or do I want it always to be pointing towards the end point? I could make it so that it was always pointing towards the end point. Like, that is definitely a possibility. In fact, I should do this in a slightly more principled way. I'll put this down here. So, like I said, normally I would write really crappy code. Instead, what I'm going to do is say divided by 4. So this distance hypotenuse is the distance between the start and the end point. So this is just a way for me to know that I'm not going to generate points like out here in the middle of nowhere. That they're at least going to be like, you know, close to this midpoint. And then the other thing I can do here is say start theta 1 is going to be sample Let me think about that for a second. For right now, I'm just going to make it generate those points anywhere. And I think later I will give myself the option to make it always point towards the other point. So we're going to sample from 0 to 2 pi. And to make the length of that arc, I'm just going to say, let's take that. So take the starting angle and then add some small amount. Like, let's say it could be like anywhere from let's say it could be anywhere from like 20 degrees to, I don't know, 100 degrees. And this is radian. This is just a function I made that converts degrees to radians, because sometimes I just write the radians like 0 to 2 pi, or like pi over 4, 3 pi over 4. But sometimes it's easier if I'm not using like the standard unit circle. It's angles, then it's easier for me to think in degrees. So I just do like that and convert it to radians. Okay, so now we have everything we need to draw an arc. We have a radius. Anything you need to draw a circle or a radius, you just need, or a circle or an arc, you just need, you need a midpoint, you need a radius, you need a start angle and an end angle. Then we can say, start is gonna be Tibble. Angle equals seek from start theta 1 to start theta 2, length dot out equals the number of points that we have, which is called lines. Then we say x equals start r times cosine of angle, and y equals start r times sine of the angle. Okay. Did I change anything here? Okay, so I'm just going to rerun this code up to this point. And I'm going to put the jitter at 0 for the time being, just so that we can focus on only one thing at a time. I didn't get any errors. That means I did something right. Cool. So those are our start points. And we can do the same thing with the endpoints then. Very simple to do that. So we're basically just going to copy this. I'll put this up here. But we do have to think about this a little bit. We have to think about this a little bit more. Okay, so the end radius is... it's going to be the same thing. Actually, it's fine. For this purpose, I don't think it matters, actually. When I was generating the Bezier curve points, it mattered, but I don't think it matters in this case. And call this, and call this. Oops, and then we need to change this one too. And how about this guy needs to be called end, and then end, and then end. And then we need to make a change. Okay, so this also needs to be end and end. And I know someone watching right now is going, why didn't you use multiple cursors? And the answer is because I'm lazy, and even though it's a time saver, I almost never use multiple cursors. I also don't use a lot of hotkeys. When people watch me program, they like lose their mind. So what we need to do for this one is shift it by that midpoint. So end x is what it's called, and plus end y. That should work. Okay. So hopefully that worked. We're gonna find out in a second. I'm doing a great job, thank you. Yeah, it's always like really surprising. Everyone watching right now is wonderful. You're all super supportive. I love you all. If you're ever watching someone code and you think like, wow, you're like really dumb, why can't you see that mistake you've made? It's so obvious. Or like, oh, this is such a simple thing to like, you know, draw a triangle or something. Why can't you do that? It is shocking how difficult it is to like code and stream at the same time. If you're used to just like sitting there and coding by yourself, it's really, really difficult to do it while you're like talking about what you're doing and while you're interacting with chat and while you're like, you know, so it's very weird. Just like things that would be so easy any other time just like leave your head and you can't remember them all of a sudden. Very weird feeling. Okay, so in this case, we need to... so this is the code for making that data structure for the Bezier curves. But now, since we have not just one start point, we have multiples, we need to like interweave these as well. So that's what I'm doing right here. Can type. Cool. Thank you, Pedro. Pedro says, this level of trigonometry that you're doing, I would need a lot of time to learn. So what I do is, you really only need, okay, so first of all, I have to plot this to see if it worked. Let me see if this worked first. Hey, it worked, woohoo. Okay, and let's just like run this a couple more times to see what happens. See if these are like nice parameters and if it makes a nice, beautiful plot. Robert's like, I'm very impressed you're able to narrate your thought process while coding. I try. I'm glad you're impressed. That bodes well for me because I do try. I feel like sometimes I am either like over or under narrating. I'm still striking that balance, but thank you. Cool. I think this is like too much. Yeah, this is like, because sometimes it's generating them here and then it's like we're gonna have to fine tune this. This is obviously not exactly what I wanted. But I mean, it is doing what I told it to do, put it that way. I think there's something weird here. It's like these points are weirdly close together all the time, and I don't know why that is. Maybe it's just random chance, or maybe I need to make the radius bigger for that. Or I think I might need to do that thing I said with the angles where the where I always make it generate an arc pointing towards the other endpoint. I think that might be part of the problem as well. But I mean, the things it's generating are kind of cool looking. Where's my zoom? I always lose. Erg. I always lose track of this thing, the plot zoom. I mean, like, it's kind of cool looking, right? I like it. Yeah, so Pedro said this level of trigonometry. Okay, so I'm not good at math. Like I'm really not, honestly. This level of trigonometry is like it's like what you learn in high school, right? So like I'm not doing anything I didn't learn in high school. And honestly, like 90% of the trigonometry you need is right here up at the top. So like, let me find, where did I do this? Okay, so this is like critical. If you ever want to do generative art or data viz or anything, knowing the conversion of like how to take a radius and an angle and convert it to XY and just like draw a circle of points, that is like 90% of the trigonometry you will use in art and in life, and in data viz. So just this whole like x is radius times cosine of the angle, and knowing how to like loop through, like create a set of angles between two things. The other thing you need to do, so there was a good bit of like geometry, trigonometry involved in figuring out how to make these control points in a non-crazy manner. That's what this is for. So I sit next to my computer with a notebook where I scribble. I don't know how well, this probably isn't in focus, but basically it's where I scribble like, I just scribble like circles and like angles and you know, random trigonometry stuff. That is crucial because it's like I've sat here for like hours sometimes just like randomly drawing thetas and stuff and trying to figure out like what the right formula is. But it's really more of a conceptual challenge than like a math challenge. You know, all I'm doing here is basically just like angles and like cosines and stuff. It's, yeah. So, yeah, I think this is cool though. I really like it. It has a... Matthias says it looks kind of like Shirley Wu's Olympics sketches. Ooh, you're right. It totally does. Yeah, these are really cool. The way that Shirley generated these, I think... Okay, yeah, she even links to this... she even links to this post. Yeah. So this guy, I mean, this is a pretty common, this isn't like a new concept, but this guy has done a really, really nice implementation, and so has Shirley, of this algorithm where you, so how this is generated, this is kind of cool for like anyone that wants to learn generative art. How this is generated is that you take a circle, and then you add some variability to that circle. So you make it, instead of like a perfect circle, you make it a squiggly circle. So it has like imperfections in the edges. And then you basically, as you can see what it's doing right here, you drag that circle across the screen. And as you drag it, you change the imperfections and the radius of the circle. So you kind of go like, and you morph it. So every time step that it changes, you're slightly morphing the circle. And then you draw it with transparency, and that's all. And that's honestly all you do. You just drag a circle with transparency and draw it again and again, and just morph the edges. And it makes this really cool looking pattern. You can see exactly here how it's working. You can watch it change as it goes across. So it's actually a pretty simple idea. Now, the implementation is a little bit trickier because there's some sort of gotcha stuff to do with this. So the way that you draw the circle, there's different ways to make that morphing happen, but to make it happen in like a aesthetically pleasing way, one thing is the circle always needs to connect to itself at the end. And that, if you're using like Perlin noise, there's a way to do that, but you know, there's sort of a trick to it. To make sure that it always meets, the end point always meets the start point. And then the other thing that you have to think about with this is to make it aesthetically pleasing, you usually want to use some kind of noise function to determine like how the morphing is happening. And so you usually have a two-dimensional noise, which is what you're making the circle out of, is like a two-dimensional noise. And that's how you're making the circle have these imperfections, is that you take a perfect circle and then you morph each point by some Perlin noise value. And then what you do to make it look nice when you drag it across the screen is that you have a third dimension of Perlin noise. So you have an X, a Y, and a Z dimension. And the Z dimension determines how how it changes. So you can think of, if you have Perlin noise and you think of it like a canvas, then you take a 3-dimensional Perlin noise and now it's a cube. And as you drag this thing across the screen, it's like you're taking slices of that cube, and each slice is one of these circles. It's a pretty cool technique. And yeah, I remember Shirley talking about how she took this code, because this guy shared his code somewhere, and she took this code and like she printed it out on physical paper and like went through line by line and like annotated what each line does, which is a really good way to understand the code. That will definitely help. It'll be painful, but it'll help. I'm also impressed that she had a physical printer, because I feel like nobody these days has printers. Whoops. I always lose track of my zoomed plot. Yeah, I'm gonna see what happens if I make, so right now I have a twist in this. I'm gonna say, what if this is false? I'm gonna see what this looks like without a twist. Oh, and I said I was gonna make this bigger. The radius here, so it goes from 0.1. Yeah, so maybe it should go from like by 5, and then this should be like 3. Let's see what that does. I think this should actually be 6. I think it should be 6. Okay. Interesting. I don't know what to make of that. Let's try it again. At this point, I'm just playing around. That looks kind of cool. I think I liked it better when it had a twist in it. And I don't know if those changes I made to the radius were good or bad. I feel like it's a little too... Yeah. Maybe it should be like 0.01 to that. What if we just make this something really big, like 10? And then the other thing we could do, I don't know, do people want to see how we would make it so that this always faces the same direction? I think I'm like sort of out of time. I might stop, but I might also try to make it face the same direction. I liked it better when it had a twist in it, by the way. And the goal eventually, for people that are wondering, is actually to take this and not just make like one single ribbon. The goal is to take this and like make a function where you can like programmatically create the ribbons and then like create a canvas where you have like hundreds of these ribbons and they're laid out in interesting patterns and they look cool. And I also have some plans for how to make it more organic looking, with the way that the control points, the way that the points are set for the start points and end points. So I'm thinking of doing something kind of similar to what I just showed you with the HTML canvas example, where I'm thinking of using Perlin noise to make it like sort of like ridged, or like give it some imperfections around the edge. And the idea is actually the original like inspiration for this plot was making something that looks like a ginkgo leaf. So where's like a high quality ginkgo leaf? So if you see these images of ginkgo leaves, they have, you know, they go out to the side here and go out to the side, and then it has this kind of like bumpy texture, and it has all these veins going through it that look really cool. So I don't know if I'm really trying to like exactly recreate the ginkgo leaf, but I'm trying to like, this is my inspiration originally, and of course I kind of like took it and played with it from there. But yeah, I think I'm gonna take off. Thank you for hanging around, everybody, but I gotta go cook dinner and, you know, take care of life. It's been a long day. I didn't get to watch any of RStudioConf. I hope it was good. I don't know if anybody else watched RStudioConf, but I was in meetings all day long, so I didn't get to watch it, unfortunately. But I'm hoping to catch some of it tomorrow, and of course they're gonna post the videos, so that'll be cool. Cool, Johanna says it was nice. All right. Thanks, everybody. Thanks, Matthias, Johannes, Robert, everybody, Pedro, everybody for sticking around. I will be streaming again next week, Thursday, 6 p.m. Probably not streaming R. I'm probably going to go back to the office. I showed this to, I think, Matthias earlier, or Robert or somebody. But this is what I'm working on for my office project. So if you want to see more about this, Office Data Viz, if you want to see more design work, Figma stuff, come back next week. So, all right. Thanks, everybody. Bye.